Alrighty guys, today is May 8th, so 5/8/17, and we are going to do 9-3 and 9-4 today because they both deal with factoring to solve quadratic equations. So my I can statement is I can solve quadratics by factoring. So you know the drill. Go ahead, pause this video, and complete the warm-up. You have four different equations here. Remember, as a quick reminder, to factor, you can have decide the signs on the factor pairs, find the factor pairs, set up the binomials, and take out the trash. So go ahead and factor these following quadratic expressions for me. Pause this video, and when you're ready to check your answers, go ahead and hit play again. So for your correct answers, number 1 was x plus 3 times x minus 12. Number 2 was x plus 6 times x plus 8. The third one, 3x plus 4 times 3x minus 2. And the last one, number 4, 5x minus 2 times 2x minus 3. If you have any questions of those, please come up and see me. Otherwise, let's get started on these notes. So it says, way back in the fall, we learned how to solve linear equations. Remember, those are equations that are like 9x plus 3 is equal to 84, meaning we had one answer, and that's because the degree on x was 1. Now, today we're going to solve quadratic equations. We've been doing that for the past couple of days now. However, with these quadratic equations, we have a degree of 2, so that means we will have 2 different answers. Go ahead and flip them to the next page for me. To solve these quadratics, to get these 2 different equations, we're going to use the zero product property. What that is in math lingo, it's for every real number a and b. If a, b is equal to 0, then a is equal to 0 or b is equal to 0. So in our own words, that's like saying when multiplying 2 terms, if the product equals 0, then at least one of the terms must equal 0. If you have any questions on that, or you think of a different way to describe that, that's fine. This is just in Miss Miller's words, but if you can think of a different solution or a different explanation, that's great. So now we're going to put this zero product property to work. So if we look down here, and then we see that we have negative x plus 7 times x minus 4 is equal to 0. So that means that either the first term is equal to 0 or the second term is equal to 0. So in the first term, if negative x plus 7 is equal to 0, to solve, I would add x to both sides. So I get 7 is equal to x. So that's my first one. And if we look over here at the graph where x is equal to 7, that checks out if we were solving by graphing. For the second term, we'd add 4 to both sides. So I'd get x is equal to 4. And again, checking out our graph, that is our 0 there. So our two correct solutions are x is equal to 7 and x is equal to 4. For B, our second example, we're going to set the first term, x plus 5, equal to 0, as well as the second term, 2x minus 6. Then we solve like we know how to. Solving linear equations takes us back to practice with chapter 2. So we have subtracting 5. So we have x is equal to negative 5. And then if we add 6 to both sides, 2x is equal to 6. Divide both sides by 2. X was equal to 3. So our two solutions are x is equal to negative 5. And if we look at the graph, that makes sense. And x is equal to 3. And if we look over here on the right-hand side of the graph, that makes sense as well. So once you get it down to two binomials, once you factor that trinomial into two binomials, set each of the binomials equal to 0 and solve for x. Alrighty, so here is a nice graphic to talk about how to solve equations by factoring. So step 1, the equation must be equal to 0. If you look over here with my smiley faces, those are the good examples. Frowny face is obviously the bad examples. Step 2, you factor it into two houses or two binomials. Remember when I talk about the mailman, how you break it up into different houses? That's talking about the two different terms. Step 3 was to use the zero product property to solve for x. And remember that's setting each binomial equal to 0 and then solving. So let's use some of those steps here, steps 1, 2, and 3, to go over some examples. I will go over some of them together, and then you guys will be responsible to go over either additional examples, but for sure you're on your own questions. So if we look here, the first step for in letter A is that we have to set it equal to 0. So we have to subtract both sides by 8. So we get x squared minus 8x minus 48 is equal to 0. Now we have to go through and factor into two binomials. Because c is negative, we're going to have one positive term and one negative. We know that x is going to go in the front of each binomial. And now we need something that multiplies to be negative 48 and adds to be negative 8. So we have positive 4 and a negative 12. Then when we solve each of these and set them equal to 0, we get x is equal to negative 4 and x is equal to 12. And if we look, we have x is equal to 12 right here, and x is equal to negative 4 over here if we would have used the graphing method. So I want you guys to go over this letter B for me, and then also do those on your own problems. So remember guys, you are responsible for these on your own problems. We will be checking some of these chapter 9 notes later this week. However, I'm just going to keep on rolling and go into 9-4. Since both of these are from factoring, we're just going to do one video so that we can move on faster and start preparing for your final. So, date's still the same. Your I can statement is still the same. You can solve quadratics by factoring. And we are going to be working with special cases and when a is greater than 1. So please make sure you do these warm-up problems for a little bit of practice. Pause this video, do these 3 problems, and when you're done, hit play to check your work. So to go over these, your first one, x squared minus 81 gets factored into x plus 9 and x minus 9. For number 2, factors into x minus 5 times x minus 5. And remember, the simplest answer is to write this as x minus 5 squared. The last example factors down after I take out the trash to x minus 1 times 5x minus 6. And I'll go over some more in-depth answers on how to factor when a is greater than 1, because that's really what we're working with today. So when we go over these today, I am just going to go through A and B with you. You are going to go ahead and do some practice problems on your own, so you'll do C and D. However, with E, don't even worry about doing E. Cross that one out for me, because it actually does not end up working as nicely as I would have wanted. That one you'd actually use the quadratic formula. So if we go up here to letter A, the first thing we have to do is make sure it's equal to 0, so we have to add 20 to both sides. When we add 20 to both sides, we are left with 3x squared minus 17x plus 24 is equal to 0. And then we're going to factor into two binomials. Because C is positive and B is negative, both of my terms will be negative. I need something that multiplies to be 24 and adds to be negative 17. So I have negative 8 and negative 9. Now, I look at the first term here, 3x, so that means 3x goes to both. Now when I take out the trash, there's only a GCF of 1 in the first term. So that means that first term stays the same at 3x minus 8. Over here in the second term, we have a 3 in common. So I'll take out the trash here. That 3 is my trash. I'm left with x minus 3. Now I make sure, remember that this is equal to 0. So now I have to set each term equal to 0. So when I set each term equal to 0, I have 3x minus 8 is equal to 0. So I'll add 8 to both sides. Get 3x is equal to 8. Divide by 3. So x is equal to 8/3. However, I will also do the same thing for x minus 3. I'll add 3 to both sides. So x is equal to a positive 3. So my two answers for letter A are x is equal to 8/3 and x is equal to 3. Hopefully you guys could write a little bit smaller and fit it all in under the A, or make sure you're writing it on a separate sheet of paper so that you do have room for your other examples. In letter B, we're going to go over this last one here together. First step, remember, is to make sure it is equal to 0, so subtract the constant from this side. So I'm left with 4x squared minus 21x minus 18 is equal to 0. When I go to factor, those two binomials will still be equal to 0, and I am left with 4x plus 3 and 4x minus 24. And the way that I got those, remember, you do 18 times 4, which would give me a negative 72. And I needed something that multiplied to be negative 72, but added to be negative 21. So that would be negative 24 and 3. Now I need to take out the trash. In this first one here, it stays with 4x plus 3 because the GCF is 1, the trash is 1. However, here I can take out a 4 from each one, so I'm left with x minus 6. So now I'm setting each of these binomials equal to 0. So I have 4x plus 3 is equal to 0. When I solve, subtract 3. Divide both sides by 4. So x is equal to negative 3 over 4. However, when I solve this one, x minus 6 is equal to 0. Add 6 to both sides. X is equal to 6. So in this example, I have two solutions yet again. X is equal to negative 3 over 4, and x is equal to 6. So please make sure that you work through these examples. Work through C and D. If you have some questions on factoring, I know that we already had our factoring quest, but that's going to come up again on the final. So please make sure you're asking. If you need help, go see the videos again on factoring. Come up and talk to me. Factoring is important for you to be able to study and solve quadratic equations. Go ahead, complete C and D, and then also complete the on your own problems. You guys are left with just these two on your own problems. So please make sure you solve each of these by factoring. Set it equal to 0, create the two binomials, and go ahead and get to work. Hopefully you guys found this as an easy review on factoring and how to solve. And if you have any questions, remember, you can always ask.